of this, and I'll post some practice vidig problems here after we're done today. So far we've been introducing this idea of an ylid, or yield as it looks like, but an ylid. And these are species that have opposite formal charges on adjacent atoms. And they've been phosphorus so far, which they are about 90% or more of the time. But you can also have a sulfur ylid. So sulfur with a positive formal charge, carbon with a negative formal charge. This is actually a useful reagent to generate an epoxide. So it's shown over here. So it smells bad when you would make this, but you could take this species, react this with a carbonyl group, an aldehyde or a ketone. This is our solvent, DMSO, at a lower temperature. And you've actually generated an epoxide. So not an alkene, but an epoxide. So let's just relatively quickly think about how this might actually work. So what we need to do is to first just generate our ylid. So just like what we did with the phosphorus. So let's first generate sulfur-containing ylid. So let's use this really foul-smelling compound, dimethyl sulfide. And let's treat this with, we'll use the same reagents, methyl iodide. It's a very reactive reagent. And this is going to react in a classic SN2 reaction. Kick out the iodide. Three methyl groups here. Something like this. And actually, why don't I draw this a little bit better? Sorry, erase the notes here. Could use any one of the methyl groups. They're all the same. I'm just going to use the one on the right there because it's a little bit further away from the others. Now what we need to do is we want to generate our ylid. So in this first step here, sulfur gave up a pair of electrons to form a bond with the carbon. It now has a positive, let me make that clear, positive formal charge. Now we need to get our negative formal charge. So what we need to do is to have a base take off one of these protons. This carbon actually is relatively acidic next to this positively charged sulfur. So as a detail, you'll end up actually seeing oftentimes the conjugate base of DMSO. So this will have a negative charge. So we've deprotonated DMSO, and that'll take a proton off to generate DMSO. Sorry, I'm so used to writing carbon. Here we go. Sulfur, carbon, now with our negative formal charge. Sulfur has our positive formal charge. So now we have our sulfur ylid. So that's step one. Generate the ylid. Step two is to do something with it. So now what we're going to do is take this sulfur ylid, which is the species here in the middle of the page, react this with our ketone, somehow get an epoxide out of it. So this is the, let's call it epoxide forming reaction. Let's rewrite this sulfur ylid, and I'm just going to collapse those two hydrogens down to make it a little bit more clear. Plus, minus. The way this mechanism is thought to occur is that if we react it with, say, this ketone, so we actually don't form that four-membered ring species. Instead, this is going to attack as a nucleophile, just like what we've seen. Move these electrons up onto this oxygen. And now we're going to end up with O-. And I'm going to actually, to make it a little bit easier to see the epoxide in the end, take this whole species here and then draw it down here. So that way the oxygen of the epoxide will be in the right spot. So we'll have our CH2 here. This is a single bond. It kind of looks like a double bond. CH2. And that's attached to the sulfur with these two methyl groups. And that sulfur has a positive formal charge. So in the end, what happens here is this is a good leaving group. So now our negatively charged oxygen can attack this carbon, kick out the sulfur, so now we had this CH2 here, which will be this carbon, and that's our epoxide. Thus we're back to dimethyl sulfide. So this sulfur ylide is a useful way to form an epoxide. Two-step reaction. So we first generate the ylide, similar to what was done with the phosphorus. So an SN2 reaction in the first step. Deprotonation by a base. The base happens to be different here. That generates the ylide. This mechanism is a little different than what it was for the Wittig reaction, in that we're not forming that four-membered ring intermediate. Instead, the nucleophile attacks. Then it looks like we have our good leaving group here, and so then the oxygen is going to attack the adjacent carbon there, forming the epoxide, and releasing our good leaving group, which is this dimethyl sulfide. Oops. Oh, all the way down. Oh. Which, again, smells pretty bad. Rotten eggs. So a question about generating the ylide. I think in particular for the Wittig reaction, if it's okay with everyone, I'm going to scroll up. I can scroll back down if necessary here in a minute. For the classic case, we'll call it, and scroll all the way to the beginning here. This looks really messy, because it is. But it's important to know how to generate this ylide here in the very top, the Wittig reagent. And so knowing that you can take an alkyl halide with triphenylphosphine, PPH3, step 1, that's an SN2 reaction, followed by deprotonation with the strong base and butyllithium to generate the ylide. That's important to know, and I could see that on an exam. Kind of like with the Grignard reagent, sometimes we had to make it, sometimes not, and so the same thing here. Some of the more sophisticated, or not sophisticated, not the right word, but like smaller details about the Horner-Emmons and other reagents, not necessarily, but I think this, we'll call it our classic Wittig reagent. One should be able to know how to make that. Okay, so that's the Wittig reaction. Overall, it's important to know how to make this reagent, as I mentioned. This is a great way of taking and converting a carbonyl group, such as an aldehyde or a ketone, to an alkene. So you can see how this would be very useful in synthesis, because you can put an alkene at the position that you want. First introduce, say, a carbonyl group, then convert it to an alkene, and you can even attach, rather than, say, two hydrogens, alkyl groups that you're interested in. And then there are two variations, the Horner-Emmons, which is mostly used to generate predominantly the E stereoisomer. It's under milder conditions. And then the more specialized case showing that there are other types of ylides, sulfur in this particular case, which can be used to make epoxides. So why don't we pause here for about 6